Hi everyone, Electrode here. I got a call from the machine shop today and part of my parts were ready, so I went and got them, and I thought I'd give you guys a rundown on what we're going to do today, which is setting the electrode on the disc with investment and then sending it all back so the bottom half of the spark plug can be made. Now, as previously mentioned, the purpose of this is to set the trajectory of the electrode at a equal path to the outside thread of this cap, so when we screw on the bottom section of the spark plug, the relative position compared to the electrode is the same as what we'll be setting now with the jig. Without the jig, doing this procedure, because there's play in this electrode, however small it might be, but remember the gap around here is 10th thou, which is really small, so this would give you an uneven surface if it's not straight in relation to that. So with this, that enables us to set everything in the correct position before the bottom half is made. The beauty about that is the investment, as it sets and expands, will lock everything in position, so in the end all the electrode and everything should be firm. Now, as I said, I'll be doing that today. What I'll be using is the phosphate bonded investment that I'll just focus. I showed you guys this before. Yeah. There's some in there. Now, with this today, I'll be using colloidal silica. I'm using colloidal silica instead of water. I mean, you can use water, but why I'm using colloidal silica is because investment has a setting expansion. You can enhance that expansion by using colloidal silica. It will still expand with water. It'll just expand more with colloidal silica. And in a situation like this, we can use the setting expansion to our benefit, because in an enclosed cavity, any expansion will enhance the contact between the investment itself and the wall, creating a bit of seal. You can imagine that yourself. If it's under pressure in there, it's going to seal better than if it's just sitting there by itself. Now, the position of the ceramic insulator I've previously set, and because I've had to tighten that up, I won't do that again, but basically all that entails is putting everything together, screwing that up so the electrode comes in and out with everything in place, and then taking everything apart so we can go to the next stage, which is now. Now, I'll just set everything up so you guys can see it. First, I'll get this in order. I've got to screw that on. Oh, I should suppose tell you how it all fits together before. Oops, bit of powder there from the investment. Anyway, there's the electrode. The disc goes on there. That sits there like that. Now, I don't know if you can see that, but the disc itself pops out a little bit further than the middle platform here. Now, the distance between this platform and the platform on top of it, which sits right on top of that disc, is just a little bit bigger than what the slots are, which are 0.25mm or 10th thou. That'll leave a little bit of extra room around the circumference out here for all the ionised air and exhaust gases and water vapour, etc., to travel around and hopefully make an even injection through the ports and down the electrode face. They'll only have the choice of going down the face, because anything that way will be all sealed up in this area here with the investment. That's the procedure we're going to do now. So without further ado, let's get everything in order and do it. Now, what I've got to do first is screw that in place, make sure that's there, the electrode, etc. So Here we go. Oops, slightly too much liquid. Now I want this runny, but not too runny. The runniness should let it get in everywhere, but again, if it's too runny, it doesn't have any strength behind it. It might break down. So a little bit thicker than that. Now, I should have 3 or 4 minutes working time, which doesn't sound like all that much, but it is. Okay, there we go. Now, what I'm trying to do is flow that down that cavity there and make sure it gets everywhere. Yeah, you can see that's filling up nicely. We don't want it to go down the electrode hole yet, because actually that might even be a bit too much. What I want to do now is set the electrode in and put some of that around the electrode. Sorry guys if I'm a bit out of picture with this, but I've got to work quick. Now, I'll get the jig. Screw everything together. All I did then was just tap it against the surface like that to let the investment that's in there droop down and seal against the bottom of the electrode. Now we'll, hang on a sec, we'll let that sit there like that for about 15 minutes or so. Now I'll put that over there, pack this up. In the meantime, I'll show you guys what else I've been mucking around with while we wait for that to set, and that's Stan's alternator. That's a picture of it up there on the screen. One particular thing I want to talk about today are these coils here. Looking at them, they're spiral coils. They're not the typical AC coil that's wound in an alternator stator. These are different. These are more like a DC motor winding. Now, I've replicated that here, And I've also been reading on Stan's literature about the transformer, and this is where he's got spiral coils and spiral coils there as well. I thought about this for a while, and I thought about the alternator core and how it works, and also pulsing the armature and all that. And having a look at the windings, I'm thinking he's not using the windings and the armature for generation in the normal way. He's using the armature to saturate the core, and the core will have a different magnetic field on that side going in reverse direction to the magnetic field of the stator. And I think it's a relationship like that which is using the collapsing field of the core on some windings to induce a voltage, while the magnetic field of the stator on other windings is inducing another voltage. But anyway, I'll get into that later. What I wanted to show you about this today was, again in his notes he talks about the windings and how they should sandwich the other windings, because the electric field or the magnetic field produced by the electric field in this winding will affect the winding next to it. And I think that goes further with the relationship that I was saying before about the core as a saturable core. Anyway, it gets a bit complicated, so I'll leave that for another time. But as you can see, there's a lot of work. I'm getting quite good at this now, rewinding the alternators. This one's quite neat. Again, this is going on spirally, like Stan's is. I've got some ideas for the middle coil, which again would look the same as Stan's, but it's a different wind to what this is. So I've got the other alternator that I had previously removed. If you can remember, the windings are there for it. I've stripped it already, but I bought some different wire. This is 0.9mm wire, and the previous wire I was using was 1mm, so I think this is closer to what Stan was using. So anyway, I got 3 rolls, or one big one actually, split it up into 3, join them together, and then I can just wind the coils once, and I've done a 3 file of wind sort of thing. So with these, what I've done, or how I put these together, is first, this is what I got from the alternator guy when he first showed me how to build the alternators. Now this is like a plasticky sort of paperish material. It's electrically insulating till, well, how many volts, I forgot what it was, but it's specially made for this. Now these squares, when you bend them like that, that's what fits here. That's these things. These are the old ones. They're still okay, so I won't put new ones yet. And the other bits that fit in there, which close everything off, those bits there, the white bits, these here, and they're again like really thin but really strong plastic. Like they're very firm. And this has to be, because when that's full of wire, you have to sandwich this in there and put it down in there like that sort of thing. So yeah, you can see that it's not as hard as it looks, believe it or not. It's quite easy. The trick is getting those pieces right. If they're right, they'll fit into these no problems. Again, with these ties, by the way, too, with what I just said about having the windings sandwich each other, like it says in the notes. At first I thought Stan did this on every brake, like every brake's got a tie in there. And I thought that was a bit of an overkill. I thought maybe he was trying to hide something or anything like that. But now that I've taken that approach in terms of the windings sandwiching each other, and as you can see there's broad windings, he's spread them out so they can like cover as much as he can and that's what I've tried to do there. You can see. Hang on, I'll just focus for you. Yeah, I've tried to broaden the windings out so they sit everywhere. After they're wound too, I also went around with a plastic hammer and beat everything into shape. And as you can see, it's quite a neat winding. It looks good. You're getting back to what I was saying before. Yeah, these ties here, I think they just keep the wire sandwiched properly. And again, I thought I'd try it. Now, when this is finished, it should sit on top of there like that. No friction whatsoever, so you make sure. And this spins. Now that's ready for the bottom half to go on, etc. So everything should be fine. Now, getting back to the plug. It should be set. Excuse me while I set the phone up. It's not completely set. Now, a little bit of the investment has gone through there. Let me focus that for you. And it's probably filled up some of the holes, but that's okay because I can get under the microscope with a small tool and pick everything out. I've even got a steam cleaner which will blast everything out if I do it pretty soon actually. So that's it. There's the jig, which screws on nicely. The length of the electrode is, get a ruler, about an inch. So I'll just clean this up and send it back to him, and when I get it back I'll post a new video. Till then, bye for now.